Alright class, today we're gonna do a lab. So, first of all, let's get you educated with some background info. First off, let's talk about temperature and energy. Temperature is the measure of the average kinetic energy between atoms and molecules.
Kinetic energy is the form of energy an object has when it's about to move.
Therefore, the Kelvin temperature of a sample will always depend on the kinetic energy of the particles in that sample. Thus, kinetic energy is dependent on temperature as shown by this Maxwell-Boltzmann graph.
Huh?
Confused? Let me help you. The Maxwell-Boltzmann distribution shows how the speeds of molecules are distributed for an ideal gas. It is usually shown in a graph. So if the graph is higher in a given region, it means there are more gas molecules moving with those speeds.
As you can see here, kinetic energy is more dispersed as temperature increases. And although the height of this curve is lower than this, the area under the curve is the same, which means that the number of molecules is the same. The process of kinetic energy transfer is therefore referred to as heat transfer. On average, warmer bodies have more kinetic energy than colder bodies, which does not mean that they have all fast-moving particles, because a faster-moving particle means more heat. It just means that they have more faster-moving particles than slower-moving particles, whereas a cold object has more slow-moving particles than fast-moving particles. When they come in contact, however, the particles collide with each other, so fast-moving particles make the slower-moving particles faster, and slower-moving particles make the faster-moving particles slower. Eventually, the molecules collide with each other in a way where both objects have the same kinetic energy or temperature and are therefore in thermal equilibrium.
MC Delta T, we're gonna learn some stuff in our favorite chem class, energy conserve, little chemist, SLP, K, half and B squared, there's so much to learn, little chemist, K depends on the time, start the countdown, 5, 4, 3, 2, 1, system to surrounding, exo endo. Positive and negative cues, system point of view, energy transferred, little chemist. Delta E is Q plus W, there's so much to learn, little chemist. Come on, let's go, little chemist. We need you, little chemist. Yeah!
Calorimetry is the process of measuring the amount of heat released or absorbed during a chemical reaction. The amount of heat or energy released is always the same amount of heat or energy absorbed because of the law of conservation of energy, which states that energy can neither be created nor destroyed. Instead, energy is transferred from one system to another or from a system to its surroundings, and the energy that comes out of the system is always equal to the energy that goes into the surroundings. The energy transfer can occur through heat exchange or through work.
Just get ready for work, 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 work. To me, I be work, 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 work. You see me do me that.
Work is energy transferred caused by forces exerted on the system by external factors. So it's like if I were to push the white button.
It is a spontaneous direction of transfer and is always from a hot to a cold body.
I don't get spontaneous.
A spontaneous reaction is a reaction that can happen without outside help. Like, I don't need outside help to get a reaction out of Queenie. I only need to hug her.
Calorimetry can be used to determine whether the reaction is endothermic or exothermic. In an endothermic reaction, energy goes into the system and the temperature of the system rises. In an exothermic reaction, the energy goes out of the system and the temperature of the system decreases. Heat capacities, enthalpies of vaporization, fusion, and reaction can also be found through calorimetry.
I'm sure you guys have no idea what Queenie is saying, so let me just make your life easier and just quickly define what these words mean. So enthalpy of vaporization is the amount of energy needed to change a substance from a liquid phase to a gas phase, while enthalpy of fusion is the amount of energy needed to change that substance from a solid to a liquid phase. Lastly, enthalpy of reaction is the change in the enthalpy of a chemical reaction. It is really useful to calculate the amount of energy per mole either released or produced in a reaction.
System versus surrounding, and then temperature can rise to fall. Q is MC delta T. Whether it's rainy or sunny, Q is very special to you. Heat absorbed, heat release, system into surrounding with a great big plate and a calorimeter. Q is MC delta T.
A calorimeter is an apparatus used to measure the heat of chemical reactions and heat capacity. There are two types of calorimeters, a bomb calorimeter and a coffee cup calorimeter. Since we don't use a bomb calorimeter in class, we aren't really going to talk about it. But we'll talk about a coffee cup calorimeter. A coffee cup calorimeter sadly has nothing to do with coffee. It's 2 cups with a lid, and the inner cup is filled with water of a known volume, and a thermometer is inserted so that the bulb is inside the water to measure the temperature. When the chemical reaction occurs, the water absorbs the heat from the reaction. Since the styrofoam cup insulates the system, we can assume that all of the energy is absorbed by the water. Practical uses for calorimetry are weather predictions, heating and cooling systems, and measuring calories in food. In order to determine the amount of heat absorbed or released in a chemical reaction, we can use this formula, Q equals MC delta T, commonly known as Q equals MCAT. Sadly, there are no cats involved in this. That would be a little dangerous. Q is the amount of heat transferred during the chemical reaction, and M stands for mass in grams, which is usually of a chemical substance or metal. C is the specific heat capacity, which is in joules over grams times degrees Celsius or Kelvin, depending on which temperature unit you use. It is the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Delta T is the change in temperature, which is in degrees Celsius or Kelvin.
For our lab, we'll be using a coffee cup calorimeter. In our lab, we will determine the specific heat of an unknown metal using a calorimeter that you'll make on your own. To make the calorimeter, place 1 styrofoam cup inside the other. Pour tap water into the calorimeter and weigh it. Find the initial temperature of the water, and find the temperature of the metal by measuring the temperature of the boiling water bath. We'll assume the temperature of the metal is equal to the temperature of the water bath. Place the metal into the calorimeter. Make sure the hot water from the outside of the tube does not drip into the calorimeter. Stir the mixture and measure the temperature in 10-second intervals for 1.5 minutes. Once your data is collected, use the equation for heat to determine the specific heat of your mystery metal and find what that metal is.
Alright, now let's do the math for your lab. So for both the metal and the water, you'll find the Q for it, and it's Q equals MCAT. And so delta T is T final minus T initial. Remember that T final for the water and the metal are the same T final. So since the final temperature is lower for the metal than its initial temperature, you'll end up with a Q that's negative. So when you set your equations equal to each other, remember they're equal to each other because the energy released is the same as the energy absorbed. You put a negative in front of the Q for the metal, which is already negative. So you end up with a positive equals a positive, but really you're doing negative Q equals positive Q. And from here, you can do negative MCAT equals positive MCAT. Ooh.
Okay, to break down what Queenie said, she means that since the change in temperature of the metal is negative, we have to set the Q, or heat, of the metal as negative in order to find the specific heat of the metal. Setting Q of metal to negative is necessary because specific heat values can't be negative. After deriving, we should have the following formula And the specific heat capacity of metal can be found given the specific heat capacity of water, which is 4.186 joules per grams Celsius.
Calorimetry? Aye, teacher. I can't hear you. Aye, teacher. Oh. Put the metal inside the styrofoam cup. Calorimetry. Find initial and final temp of water. Calorimetry. C is your specific heat capacity. Calorimetry. Unit C is joules over gram Celsius. Calorimetry. Ready? Q is MCAT.